Welcome to Defenders, the teaching class of Dr. William Lane Craig. Today, The Existence of God, Part 9. And for more information and resources, go to reasonablefaith.org.
Well, we've been talking about the beginning of the universe, and I've shared with you two philosophical arguments that have been defended by the great medieval Muslim theologian Al-Ghazali. Now, before we look at scientific confirmation of this premise, is there any question left over that you want to ask about either of the two philosophical arguments for the beginning of the universe? Either the argument based on the impossibility of the existence of an actually infinite number of things, or the argument based on the impossibility of forming an actually infinite collection by adding one member after a time. Steve?
That only applies for in this universe?
Well, it would apply to all space-time reality. So if our universe is just a part of a big multiverse, it would apply to the multiverse as well. These philosophical arguments would even apply to God. There couldn't be an infinite regress of events in God's life either, which is why you get back to, as I said, a timeless, changeless being in which there are no events occurring.
But does it apply outside of space-time?
Well, no, the first argument would apply outside of time. If you had, say, an actually infinite number of things that existed not in time, but they were countable, the first of the two arguments would count against even that. The second argument would only count against things that are in time, because it has to do with how a collection is formed by adding one member after another, and that implies change in time. So the first of the two arguments would apply to anything that exists, even if it's non-spatiotemporal. The second argument could apply to things that are not in space, like God himself, but it would only apply to things that involve time.
Would the first argument apply against an infinite set?
If you're a Platonist, I see now where Steve is going with this. Suppose you think that numbers really exist, that numbers are objects that exist independently of our minds out there. Yes, it would apply against that. It would show, I think, that you can't have an actually infinite number of numbers. And fortunately, I don't think we're forced to accept a Platonistic metaphysics which thinks of numbers as these sort of abstract objects existing independently of human cognition. You remember right at the very beginning of that argument, I talked about Cantor's theory of infinite sets, and I suggested this is simply a universe of discourse that's governed by certain axioms and conventions, and they show us how we can construct this universe of discourse to talk about infinites in a logically consistent way without contradicting ourselves. But that doesn't mean that this universe actually exists anywhere. As my wife likes to say, just because you can draft it on paper doesn't mean that it's actually in reality or descriptive of reality.
Unless you're an idealist.
Well, not an idealist, a Platonist. A Platonist is somebody who thinks that there are these abstract objects. And this would be consistent with there being a finite number of abstract objects, but not an infinite number. But if you're so deeply committed to Platonism that you don't like the first argument, well, you still got the second argument. Okay, any other comment on either of these two arguments? Yes, Dennis.
What actually limits the number system from being infinite? Is it that it reaches a point where it has no physical meaning, or what exactly is that?
Well, this would be a good question. If you do think that numbers really exist, independently of human minds, but that they're not infinite, then you would probably be some kind of a constructivist, where you would think that numbers are constructed, say, by adding 1. The way you get 3 is you add 1 to 2, and the way you get 4 is add 1 to 3, and so forth. And that numbers are therefore sort of human constructions, much the way, say, fictional characters are, or musical works, or novels. And so you could say that they exist, but they're just potentially infinite because you can keep on adding 1 and construct them in that way. Now, that's not the route I go. I don't see any reason to go down that road. But if you did want to hold to a sort of marriage of Platonism and finitism, you would adopt a philosophy of mathematics which is called constructivism or intuitionism, which would think of numbers as constructs that are not invented, not discovered, but rather constructed. Okay, any other question on either of those first two arguments? Well, now, during the Middle Ages, people had no scientific evidence for the beginning of the universe. Al-Ghazali appealed to philosophical arguments in order to support the second premise. But in one of the most remarkable developments of modern science, there has emerged in the course of the 20th century pretty strong evidence that the universe is not eternal in the past, but in fact had an absolute beginning. All through history, people assumed that the universe as a whole was unchanging. Now, of course, things in the universe were moving about and changing in various ways, but the universe as a whole was just there, so to speak. And this was also Albert Einstein's assumption when he crafted the general theory of relativity, or his theory of gravity. And in 1917, Einstein began to apply his theory of gravity to the universe as a whole. And when he did so, he found that there was something terribly amiss. His equations predicted a universe which was either blowing up like a balloon or else collapsing in upon itself. And not knowing what to do with this problem, Einstein solved it, in quotation marks, by fudging his equations. He added a new term to his equations in order to enable the universe to walk this tightrope between exploding and imploding. But the Einsteinian universe was incredibly unstable. Even the transportation of matter from one part of the universe to another would upset the balance and cause the universe either to expand or to implode in upon itself. During the 1920s, the Russian mathematician Alexander Friedmann and the Belgian astronomer Georges Lemaitre, by taking Einstein's equations at face value, were able to craft independently of each other models of the universe which predicted an expanding universe. And in 1929, the American astronomer Edwin Hubble, through tireless observations of the heavens at the Mount Wilson Observatory, made a remarkable discovery which verified Friedmann and Lemaitre's theory. He found that the light coming to us from distant galaxies appears to be redder than it should. And this red shift in the light from distant galaxies was most plausibly explained by the fact that the light sources, the stars, are moving away from us, and therefore the light rays emanating from them are stretched so that they appear to be redder than if the objects were stationary. Wherever Hubble trained his telescope in the night sky, he discovered this red shift in the light from the distant galaxies. It appeared that we exist at the center, at the very heart of a cosmic explosion, and that everything else in the universe is flying away from us at fantastic speeds. Now, according to the Friedmann-Lemaitre model, we're not really at the center of the universe. It just appears that way. Any observer associated with any galaxy would look out from his vantage point and see this red shift in the galaxies around him, so that any observer will feel as though he were at the center of the expansion. And the reason for this is that it is space itself that is expanding. The galaxies are actually at rest in space, but they move away from each other as the space itself stretches and expands. Now, to get a picture of this very difficult idea, imagine a balloon with buttons glued to the surface. The buttons are stuck in place. They're at rest with respect to the surface of the balloon. Nevertheless, as you blow up the balloon, the buttons will get farther and farther apart because the balloon is getting bigger and bigger. Because the surface of the balloon is stretching, the buttons will move away from each other in the sense that the distance between them increases, even though they are themselves at rest with respect to the surface of the balloon. Now notice that there is no center to the balloon's surface. Any observer located on one of these buttons will look out and see the other buttons receding from him, moving away from him. There is no center to the balloon surface. Now, someone might say, but there's a center inside the balloon. But then you're forgetting, we're talking just about the surface of the balloon. Just the two-dimensional surface of the balloon has no center. And those galaxies, or rather those buttons, are just like the galaxies in outer space. The two-dimensional surface of the balloon is the analog to our three-dimensional space. And the buttons represent the galaxies in space. The galaxies are actually at rest in space, but they move away from each other as space itself expands or stretches. And just as there is no center to the balloon surface, so there is no center to the universe. Now, eventually, the Friedmann-Lemaitre model came to be known as the Big Bang theory of the origin of the universe. And I think you can see from what I've said that that title, though catchy, is somewhat misleading. For to think of the expansion of the universe on the model of an explosion is misleading, because we might think then that the galaxies are moving out from a central point into a pre-existing empty space. And that would be a complete misunderstanding of the model. The model is not that the galaxies were once located at some central point and are now moving out into a pre-existing empty space. The model is much more radical than that. The Big Bang did not occur at some point in a pre-existing space. Rather, it is the space itself that is expanding. Now, you might say, well, but what about that point in the interior of the balloon? If the balloon shrinks down, wouldn't it collapse down to that point? Well, but then again, you're forgetting that the analogy to space is just the surface of the balloon. The balloon surface happens to be embedded in a third dimension, a higher dimension, so that there is depth as well as breadth and length. But on the Big Bang theory, our three-dimensional space is not embedded in some higher fourth dimension, so that there just is nothing that corresponds to the space inside the balloon or outside the balloon. Our three-dimensional space is the analog, or is like, the two-dimensional surface of the balloon, which has no center. So, don't be misled into thinking of the Big Bang as the explosion of a super dense pellet which has been around from eternity and then a finite time ago suddenly blew up. That's not the theory. Now, any question about this so far before we move on? Okay, over here.
Bill, a while back we watched the Privileged Planet film, and they talked about our special location in the universe that we basically, it would be described as we have a spectacular view.
Yes.
And so wouldn't that somewhat go against the idea of centrality of the placement in the universe? In other words, there's a specific...
Well, what the Privileged Planet is talking about is our location as a planet in one of the spiral arms of our galaxy, so that we can make visual observations of the universe rather than have the heavens be obscured. But that's just within our galaxy. What we're talking about here with the Big Bang model is all of the galaxies and the galactic clusters, a much larger scale than just our location in our galaxy. Here, we're abstracting to really, really big scales, where you think of the galaxies scattered all across the universe. And it's these galaxies and clusters of galaxies that are fleeing apart from each other at fantastic speeds. But within our Milky Way, within our galaxy, things are hanging together in this spiral arm structure.
How does this relate to the biblical perspective of as God described mankind's creation and the earth's creation in the grand scheme of things?
Well, I think that what we have to say is that mankind is not the center of the universe in any sort of physical sense. But I don't think that is ever taught in the Bible. It nowhere suggests that we are physically located at the center of the universe. Rather, the Bible presents human beings as the apex of creation, the crown of creation, in view of their being created in the image of God. And that's what makes them special. And that's independent of their size. You don't have to be big to be morally worthy, to be intrinsically valuable. Human beings are intrinsically valuable because they are created in God's image. And in fact, biologists tell us that the human brain is the most complex structure in the entire universe. So the fact that we're dwarfed by the universe's size doesn't speak to our intrinsic worth or our importance in creation. It's not based on our size or location. Joe?
So not a super dense pellet, but a formerly non-existent flat balloon, or
Well, I'll say something more about that in a minute. What it would mean is that this geometry shrinks down to a boundary point before which it doesn't exist. And I'll say something about that in just a minute. But you shouldn't think of this pellet as existing in a sort of big vacuum or big empty space, lying there from eternity and then inexplicably blowing up a finite time ago. That's not the idea. It's time and space themselves that come into being at the beginning of the universe. But I'll say something more about that in just a second. Any other question so far? Yes?
I have one additional question, and that would be how this theory would relate to Genesis 1:6, and God said, "Let there be an expanse in the midst of the waters, and let it separate the waters from the waters." And then, of course, we're told later that the stars themselves were placed within the expanse of the heavens. And so, would you say that if this theory is true, that would mean that from the perspective of any planet, it would appear as though there an expanse had been placed in the midst of the waters?
I am very loath, very reluctant to try to read modern science into the Bible, and in particularly into Genesis 1. I think that is what's called eisegesis. That is, say, you're reading into the text, you're reading between the lines, rather than exegesis, which is allowing the text to speak to us in the way that an ancient Hebrew writer would have thought and read about these things. So I respectfully disagree with my friend Hugh Ross, who would quote verses like that, or Isaiah when it says he spread out the heavens, and interpret this as a biblical prediction of the expansion of the universe. I think that rather, in its original context, what this ancient Hebrew writer was thinking of was of the heavens on the analogy of a tent that God has constructed, and you see the lights in the firmament, or in the expanse. But that's purely a phenomenal description. That is, it's a way things appear to us. And we shouldn't think that he's trying to give some sort of sophisticated astronomical theory. Yes, you want to follow up? Go ahead.
Even if things are being described in phenomenological terms,
yes.
Wouldn't you say that those terms still represent something? That they represent something in reality, even though they may have been described from the perspective of the biblical
Fair
writer.
enough. Yeah, I think that's right. And so I would take Genesis 1:1, in the beginning God created the heavens and the earth, to be a statement of the origin of the universe. That would be what we would call the Big Bang, that God created the Big Bang. And then in verse 2 it says, and the earth was without form and void. There the focus has suddenly narrowed in a dramatic way to this planet. And what is then described is how God transforms this planet from an uninhabitable waste to a place suitable for human beings to live and thrive. And he creates an ecosystem in which they can flourish. So you're right, I do think it does correlate. I just am reluctant to try to look at words like expanse and think of those in terms of, say, expanding universe, or try to read modern cosmology into those things. But I think you're quite right in saying this isn't meant to be just poetry. It doesn't mean to describe real things. Yes, Taiwan?
I think it's the perspective. Since the earth is the center of God's creative purpose, but yet if we look at just the solar system from the from the Earth's perspective, the solar system will seem very complicated. We have to come out of that perspective, go into the sun, then everything is in order. So if we stay in our perspective, everything will be so complicated, but we have to get out of our perspective to a higher perspective where everything will fit together orderly.
Well, I think you're right in saying that there are different perspectives from which to look at it, but I would think of these not so much as physical perspectives as what I was saying in response to Robert, that you look at humanity from the perspective of its ethical and spiritual importance. And it's in that sense that human beings are the crown of creation and the center of creation, in a sense, in that they are created in the image of God, and therefore are intrinsically valuable, so that God would send his son to die for them. But our planet, considered from this sort of third-person physical perspective, is this little speck of dust that's just lost in the Milky Way, and the Milky Way is just lost in this enormous universe. But that doesn't say anything about the importance of human beings, because importance, as I say, isn't determined by size. And that's the fallacy of sometimes atheists or agnostics, who, because we're so small, think that therefore we're insignificant. That's a fallacy based on thinking that significance is determined by how big something is. Okay, good. Well, okay, well then I agree with you. All right, now, as we trace this expansion back in time, that means that everything gets closer and closer and closer together as you trace the expansion in reverse. If our balloon had no minimum size, but could just keep shrinking and shrinking and shrinking, then eventually the distance between any 2 points that you pick on the balloon would shrink to 0. If it could just keep on shrinking, then eventually the distance between any 2 points on the surface of the balloon would shrink to 0. It would have, in effect, 0 circumference as its measure. And according to the Friedmann-Lemaitre model, that is what happens as you trace the expansion of space and time, or space back in time. Eventually, the distance between any 2 points in space becomes 0, and you can't get any closer than that. And at that point, you have reached the boundary of space and time. Space and time cannot be extended back any further than that. It is literally the beginning of space and time. So we could portray our expanding universe geometrically by means of a cone. If we let this disk represent the three dimensions of space and time. One dimension we have to suppress because it's on this blackboard. If we let the disk represent the three dimensions of space, and the vertical dimension be time, then as you trace the expansion of the universe back in time, the universe shrinks down to a point at which the distance between any two points in space is 0. And that marks the beginning of space and time. Now, what's significant about this is that the geometry of a cone is such that the cone can be extended indefinitely in one direction. You can keep adding to the cone in that direction. But in the other direction, a cone has a boundary point and cannot be extended any further. The cone can only be extended geometrically in the one direction. In the other direction, it has a boundary point. Now, since that direction represents time, that means that at some time in the past, space began to exist. That there is a boundary point before which nothing existed. What this implies, therefore, is that the past is finite and that time and space had a beginning. Now, because space-time is the arena in which all matter and energy exist, this means that all matter and energy also came into being at this point. It is the beginning of the universe. Now, notice that there's simply nothing prior to the beginning of space and time. Now, let's be philosophically careful here so that we're not misled by words. When I say there is nothing prior to the beginning of space and time, I do not mean there is a prior state and it is a state of nothingness. When I say there's nothing prior to the beginning, I don't mean there is a prior state which is a state of nothingness. Rather, what I mean is that at the beginning point, it is false that there was anything prior to the universe. At the beginning point, it's false that there was anything prior to the beginning of the universe. It's false that there is something prior to that point. That's what one means when one says there's nothing prior to the beginning. So, the standard Big Bang model, as the Friedmann-Lemaitre model came to be called, thus predicts an absolute beginning of the universe at some time in the finite past. If this model is correct, then we have amazing scientific confirmation of the second premise of the Kalam cosmological argument. Any question about this implication? Yes, let's go to Don here. He hasn't asked a question yet.
Bill, my question would be this. Is there anything theoretically that prevents that from being an hourglass?
Yes. If this is what's called a singularity, then it represents a boundary point to space and time, and you cannot extend space-time through a singularity. So a lot of the project of current cosmology is to try to get rid of this singularity at the very beginning so as to extend the universe through. And we can talk about that later on, but right now, insofar as we are talking about the standard model, the Friedmann-Lemaitre model, it does feature a singularity and therefore has a boundary point and cannot be extended like an hourglass. That would be a different geometry than a cone geometry. Okay, next question. Yes, Jonathan.
What would you say to somebody arguing perhaps that the singularity simply results from a breakdown of the mathematics, and that because you're not actually at zero when you reach the singularity, it's like 10 to the negative 40 seconds or something like that, and there's still a fraction of time before the universe hits point zero?
Actually, no, the singularity is at t equals 0, Jonathan. If the universe begins like the standard model has, it's t equals 0. It's not prior to that. I apologize. I was thinking we'd get out at 12:30. And I was looking at my watch and thought, gee, how come we got so much time left? This is great. So I'm sorry for going overtime. But actually, we're at a good breaking point now. And so what we need to discuss then is the Standard Model correct? The Standard Model unequivocally predicts the beginning of the universe. The question is this model correct? Or more accurately, more importantly, is it correct in predicting a beginning? And that's the question we'll take up next time.
The copyright for the content of this recording is held by Dr. William Lane Craig. For more, go to reasonablefaith.org.